So, related to exponential functions are logarithmic functions. But to get to the logarithmic functions, we need to understand what a logarithm is first. So let's go back and talk about logarithms. How many people have worked with logarithms before? A few have, good. How many people can use log tables at school? Can anyone remember using log tables at school? Is anyone as old as me? You did? Brilliant. We're kindred spirit then. I remember, because we didn't have calculators when I was at school, and we had to do all of our arithmetic with log tables. And they were really good because you could write on the inside cover and you could cheat like crazy. But other than that, not that that's what I did. I didn't cheat. Here we go. This is important. We're going to repeat this statement 6,000 times at least. It says, the logarithm of a number to a given base, where that base is positive and not 1, is the power that the base must be raised in order to equal that number. Does that make sense? Let's do an example, I think is probably the best thing. So in here, if I were to cover that up just for a bit, this says, the log of 100 to the base 10. So this is the log to the base 10. That's our notation for it. Here, that log to the base 10 is the power that 10 must be raised in order to give 100. And of course 10 squared is 100, so the log of 100 to the base 10 is 2. So 10 must be raised by 2 to give 100. That's what that says, that's what that says. So that statement and that statement are the same, say the same thing. And you can see that logarithms are related to exponentials. In fact, one undoes the other, but we'll come to that in a minute. So get your head around that sentence, because as I say, we're going to repeat it over and over and over. So for example, what will be the log of 1,000 to the base 10? That says, what power must 10 be raised in order to give 1,000? 3. Because 10 cubed is equal to 1,000. The log of 8 to the base 2. What power must 2 be raised to give 8? 3. Because 2 cubed is equal to 8. I'll come down here and do C down here. Log of 81 to the base 3 says 3 to what power gives 81? And I think it's 3 to the 4. So therefore the log of 81 to the base 3 is 4. So it sort of makes sense, I hope. D says, what power must 10 be raised in order to give 500? Don't know. But I do know this. Look, I know that 10 squared is equal to 100. I know 10 cubed is equal to 1,000. So the power that 10 will have to be raised to give 500 is going to be somewhere between 2 and 3 in here. So that will tell me that 2 is less than the log of 10 to the 500. Log of 500 to the base 10, I should say, is less than 3. It's somewhere between 2 and 3. And at this point, we say, oh, I don't know what it is, and we get out our calculator. It will have a log button on it, and that log button, the log button, will be log to the base 10. And if you ask your calculator, I believe, so I'll say via a calculator. Via a calculator, we get that the log of 10 to the 500 is something like 2.699. 2.699 to 3 decimal places. So that means that 10 raised to the power 2.699 is approximately, it won't be exactly, but it'll be very close to 500. How your calculator works that out, well, you'll have to wait until you get into Math 1120 before we can show you that. Okay? That's something to look forward to, yeah? Yeah, I'm sure you can't wait. All right. So for some examples, we can actually write down the numbers quite easily, but for others, we have to resort to the calculator. Your calculator has 2 log buttons on it, and the log button is certainly the log to the base 10. We'll talk about the other button a bit later. So as I said before, these 2 statements are equivalent. Log bx, the log of x to the base b being y says b to the y is equal to x. They are equivalent statements. You can go from one to the other. Always with the caveat that our base here is positive and not 1. And I guess in here, we said before that the range of our exponential function was all values greater than 0. So when we come back the other way, we say, look, we can only work this for positive numbers. Okay? So you can't, if I had a negative number in there, just say I had -2 and this was 10, 10 raised to, wouldn't matter what power you choose, you can't get a negative number. 10 raised, if you raise 10 to a power, it won't be negative. So we can only ever find the logarithm of positive numbers in there. So let's do a few more. It says find log 2 of a quarter. So log 2 of a quarter. Now in this case, what you're supposed to do is you're supposed to recognise that a quarter is, or 4 is 1 on 2 squared, and 1 on 2 squared is 2 to the -2. So it says, what power must 2 be raised to give 2 to the -2? And the answer is -2. So the logarithm can be negative, but I can't find the log of a negative number. i.e. 2 to the -2 is a quarter. Same thing. So in this case, we could evaluate this without our calculator because we could express this quarter in terms of 2. When we come to the next one, can I express 3 in terms of 10? Not easily. So B says find the log of 3 to the base 10, and I don't know what that means, but I do know, I'll come back and fill in the answer here, but I do know that 10 to the 0 is equal to 1, 10 to the 1 is equal to 10, so this logarithm is going to be between 0 and 1. So that tells me that 0 is less than the log of 3 is less than 1. And I get out my calculator and it turns out to be something like, so I'll say approximately 0.477 to 3 decimal places. And so what that tells me, i.e. 10 to the 0.477 is approximately 3. And 0.477 is definitely between 0 and 1. The last one says, if the log of x to the base 5 is 1.35, what's the value of x? Well, again, we go back to our sentence. We say the log of x to the base 5, 1.35, says that 5 raised to the 1.35 must be this number here. That statement and this statement are the same thing. 5 to the 1.35 is equal to x. And so now I can get my calculator out and work out 5 to the 1.35. So I can say, therefore, x is equal to something about 8.782 to 3 decimal places. And again, via the calculator. I couldn't do that in my head. So via the calculator. But this one's just trying to say, do you understand what that statement says? And this is what it says. One thing that I forgot to mention up here, and I probably should have, is that if you're asked for the exact answer of something like this, that's as good as we can do. That's an exact answer, log 3 to the base 10. I can't do it any more accurately than that. That's what I can write. That is an approximate answer, so that's an approximation. So if you were asked to leave something in exact form, you'd actually have to leave it like that. Can't simplify that any further. In this case up here, I could simplify it further. I could get down to -2, but not in this case. So basically, that's all there is to logarithms in terms of concepts. A little bit more notation and terminology, though. So